When we build modern, highly energy-efficient homes, we take great care to keep the cold winter weather outside. But by making a house perfectly airtight and sealed up tight against the elements, we accidentally create a very specific physical reaction. This animated diagram shows a cross-section of our house and the ground beneath it. As the warm air inside your home naturally rises, it reduces the air pressure on the lower levels. Your house needs to replace that air, so it acts like a high-performance vacuum, pulling replacement air from the path of least resistance, the dirt directly under your foundation. The issue is that soil naturally produces an invisible radioactive gas called radon, and because your home is so well sealed, that gas gets pulled out of the earth and pools directly in your living space, where it becomes a leading cause of lung cancer. Now, there is absolutely no need to panic. The ground beneath your home is perfectly safe, and we don't need to change where you live. We simply need to control how the air flows. We do this by installing an active radon mitigation system. Think of this as an artificial airway for your house. It safely intercepts those soil gases before they ever cross your foundation. Building a safe, highly efficient home doesn't mean giving up on insulation or accepting drafty windows. It simply means taking deliberate control of your internal air pressure, allowing the house to breathe exactly how we want it to. To see how we control that pressure, let's look behind the walls at the two main components that make this system work. The first piece is a specialized inline fan, which pumps the air through the system. But we can't just put this fan anywhere. It must be placed high up in an unconditioned space, like your attic. We never want to put this in the basement. This diagram illustrates exactly why that high placement is so critical. By putting the fan in the attic, the entire length of the pipe running through your living space remains under what we call negative pressure. If a small crack ever forms in the pipe inside your house, the fan will safely suck your room air into the pipe. Contrast that with what happens if we move that fan down to the basement. Now the pipe above it is perfectly pressurized. If that pipe develops a leak, the fan will actively blow highly concentrated radon gas straight into your family room. Since this is an invisible gas, you need a way to know the fan is doing its job without having to climb up into the attic or earn a science degree. For that, we install a manometer on the side of the pipe in the basement to act as your daily dashboard. This close-up graphic of a U-tube manometer shows you exactly what to look for. It's a simple tube filled with colored liquid. On the left side of this graphic, the liquid levels are uneven, which proves the fan is successfully pulling a vacuum. On the right side, the liquid is perfectly level, telling you immediately that your fan has failed and needs attention. Together, the fan in the attic and the manometer in the basement actively remove dangerous gas from the soil, while giving you an instant, simple visual check that your home is safe. Now, having a strong fan is great, but we have to ensure it pulls air from the correct place. To do that, we need to fix the biggest vulnerability on your basement floor. Most homes have a sump pit to collect groundwater, but a standard sump pit usually has a loose plastic lid resting on top. That loose lid acts as a giant hole in your floor, completely short-circuiting the vacuum we just worked so hard to create. Look at this technical illustration to see the upgrade. Instead of that gapped plastic lid, we install a heavy-duty cover that bolts down directly to the concrete. It uses thick rubber gaskets around the edges and the pipes to create an airtight seal. This forces your radon fan to pull air from the dirt beneath the house, rather than just stealing warm air out of your basement. Once the physical system is sealed, we need to track our success. In the past, builders would have you leave a charcoal canister on your shelf for a few months and then mail it to a lab. But that outdated technology only gives you a single snapshot in time. Radon levels fluctuate wildly depending on the season and the barometric pressure outside. To get an accurate picture, you want a continuous digital monitor in your home. This gives you a rolling average and can send alerts straight to your phone if levels spike during a heavy winter cold snap. By sealing the gaps in your physical floor and using real-time digital tracking, you guarantee that your system provides continuous, active protection against an invisible threat. Now that you understand the science of airflow, you now have the tools to walk into a finished basement and spot poor construction practices right away. First, watch out for the short vent. If the exhaust pipe on the exterior of the house exits near a window or your fresh air intake, the system will just suck the dangerous radon gas right back into your living room. The pipe must vent clear above the roofline. Second, you need to listen for noisy vibrations. If the builder bolted the radon fan directly to the wood framing without using rubber vibration isolators, you will hear a low, constant hum echoing through the entire skeleton of the house. So when you meet with your builder, ask them 2 specific questions. Can you confirm the radon fan is located in the attic to ensure negative pressure inside the living space? And can you verify the sump pit is sealed with a fully gasketed bolt-down cover? A perfectly sealed, highly efficient home is an incredible achievement. But to live in it safely, you must take charge of the airflow rather than accidentally becoming a victim to it. Thank you for taking the time to learn about the health of your home today.
If you found this helpful, please like the video and subscribe to the channel so we can keep making complex building science easy to understand. See you on the next project.